Don't worry about that one. But they're all the same. So, yeah. All right, so I'm going to go to Unit 4. Actually, it would be easier. Do what? Okay. All right, so I'm going to start from the back and work our way backwards. So let's start with quiz number 5, which was Friday. All right, so what this is going to do is it's going to look at the ones that we got the least percent correct on. Yay, everybody got carbon dioxide. Yes. See, y'all know how to do it. All right, so number 9 posed some problems. So give the formula for the following compound, silver oxide. And I'm waiting for the question to pop up. So with the first thing you need to recognize is that silver is a metal. So if silver is metal, what type of question do I have? Is it, or what type of compound do I have? Is it covalent, ionic? What? Acid, base? What is it? If I have a metal. Metals and nonmetals together are what type of compounds? We have 3 choices: ionic, covalent, or metallic. Okay, so that needs to be the first thing y'all write down. Okay, and that's stuff we learned way back in Unit 3. All right, so write this down. Ionics are metals and nonmetals. Because if you don't recognize that, you don't know which rules to go by. And naming compounds and formulas is just memorizing a set of rules. That's it. There is no understanding. There is no comprehension. There is no analytical thinking. It's memorize the rules, follow the rules. But if you don't know what kind of compound it is, then you don't know which set of rules to follow. So if you have a metal and a nonmetal, it's ionic. Silver is a metal. I know that silver is a metal because it is in the middle and left side of the periodic table, which you will have. So if you have anything in the middle and anything on the left side of the periodic table, that is a metal. Okay? So silver is a metal. Oxygen is a nonmetal because it's on the right side of the periodic table. So the next thing I have to do is I have to remember and have to have memorized, again, naming compounds, just about memorization. That's it. I have to have memorized that oxygen is always a -2 charge. Always. It's -2 because it's in the 16th column of the periodic table. Okay? Silver is an exception. Normally, I tell you, if it's a transition metal, you have no way of determining its charge. But silver is the exception. Silver only has one kind of charge. That's it. Okay? And that is a +1. So that might be the second thing that you want to write down. Silver is always a +1 charge. Okay? And just have that one memorized. Okay? Most transition metals you can't tell. Silver is the exception. So if silver is a +1 and oxygen is a -2, which of those formulas would have to be correct? The first one. Because charges have to balance in a compound. In all compounds, the charges have to balance. So if silver is a +1 and oxygen's a -2, I have to have two silvers to balance that out. Okay? Does that make sense? Okay. And our scores on this were not bad. I had 45% of us get it right, which is not terrible. I've had worse questions. So let's look at the next one that caused some issues. And like I said, we've done 5 of these quizzes, and they're all basically the same thing. Okay? We're going to follow the same rules every time. That's it. All right, so with this one we have the formula, and we have to give the name. Okay, so I need to look and see, are these metals and nonmetals? Is it ionic or is it covalent? Okay, so looking at this, do I have a metal in this formula? Do I have something that's on the left side or in the middle of the periodic table? So get your periodic table out, look up Ba, and look up P. Yes. Ba is in what group? Huh? It's in the metals, but what group specifically is it in? 1, 2, 3. It's in group 2. So Ba is a group 2. So if it's group 2, what charge does it always have? Again, something we learned way back. Everything in the second column of the periodic table has what charge? 2. Everything in the first column of the periodic table has what charge? 1. Okay? Groups 3 through 12, you can't really tell, except for our exceptions. There are transition metals, so we don't really know. Group 13 is a 3. 14 is a 4. 15 is a -3. 16 is -2. 17 is -1. Okay? Have to memorize those charges. Have to. So if Ba is a +2, all right, now, Ba is a +2, that means it's a metal. So what type of compound is this? Ionic or covalent? If I have a metal in it, is it ionic or covalent? Ionic. Very good. So if you look at the rules for naming ionic compounds, do those rules include prefixes like dis and tris? No, they do not. So I can count that one out. Okay. Now, the other thing you have to remember is, now let's look at the P. P is a nonmetal, but what do we call just P? What do we call it? When naming ionic compounds, the second element, what do we do to it? We change the ending to something. What do we change it to? IDE. Exactly. We change this to IDE. So that takes out that one. Okay? So now we need to decide, is this barium 3 phosphide or just barium phosphide? Okay? The Roman numeral, so this might be the third thing that you want to make sure you write down somewhere, is that Roman numerals are only for transition metals. Only for transition metals. And they tell me the charge of that transition metal. Is barium a transition metal? Is it in the middle? No, it is not. So do I need a Roman numeral? No, I do not. Put an X over it. So it has to be this one down here, barium phosphide. Okay? How are we doing, Aubrey?
Good.
Okay. Got it? So far, the big things that I've told you to write down are that ionic compounds are metals and nonmetals. Transition metals are the only ones that have a Roman numeral. And that silver, even though it's a transition metal, doesn't need a Roman numeral because it can only be +1. That's it. Okay? All right, so let's take a look at another one. Taking this time. So as far as studying for the test, I would go back in my notes, study and memorize so that you can just spit them out of your mouth. Memorize the rules for naming ion compounds, rules for naming covalent compounds, rules for naming acids. Okay? And then know ionic means it has a metal in it. Covalent doesn't have any metal in it. All right. So give the formula for the following compound, aluminum nitrate. So the other thing we have to go back and make sure we have memorized is our polyatomic ions. Okay? So aluminum, we know that that is Al. And what is, look on your periodic table, what is the charge for aluminum? +3. Okay? Now, with polyatomic ions, you just have to have them memorized. There's no way to figure it out. There's no chart to look at. You just got to memorize it. Nitrate is NO3. Okay? And you also have to memorize the charge on it, and it's a -1 charge. Okay? And that stays the same all the time. It never changes no matter what. Nitrate is NO3, and it's a -1 charge. That's why it's easier just to memorize it. Okay? So we know aluminum's +3. We know nitrate's -1. So the only possible option would be which one? First, second, third, fourth? Anybody? If it's this one, let's see if the charges balance out. So we're saying we have 3 aluminums and each one is a +3, so that would make that a +9. Nitrate is a -1 and I have 2 of them, that makes that a -2. That doesn't balance out, does it? So that can't be it. This is +3. Each one of those is a -1, so that makes -3. That balances, doesn't it? Okay, down here, aluminum is a +3. Nitrate is a -1. That doesn't balance. Down here, we got +6, because 3 times 2 is 6. That's not even the right formula for nitrate, is it? So that one can't be it either. Okay? All right. Name the following compounds. All right, so we have a K, and we have 3 other elements in there. So this might be number 4 that you want to write down. Number 4. More than 2 elements means you have a polyatomic ion. Okay? More than 2 elements means you have a polyatomic ion. So I have K, H, C, and O. That's 4 elements. 2 or 3 of those will be a polyatomic ion. So you got to have them memorized. Okay? HCO3 is the polyatomic ion bicarbonate. And again, you just got to memorize it. And it has a -1 charge. Okay? So potassium, what charge does that have from the periodic table? Because again, you've got to refer back to the periodic table. I don't expect you to try and memorize all of these charges for all of these metals. That's too much. Learn how to use the periodic table. So what column of the periodic table is potassium in? K. Column. K. No, K is not in 5. Just K.
Okay.
K.
So I was repeat.
Oh, you were doing P. Oh, okay. K is in group 1. I was going, why is she saying 5? Okay. So K is a +1 charge because it's in group 1. Okay. So does potassium need a Roman numeral? Nope. So we can take that out. Potassium carbonate, that polyatomic ion is not carbonate, so we can take that out. Do things with metals have a prefix? No, so we can take that out. So there we go. Now, if you don't know your polyatomic ions, you might think, oh, but that has a prefix bi. No, that's not a prefix. That's the name of the polyatomic ion, bicarbonate. So you gotta have your polyatomic ions memorized. There is a Quizlet for these polyatomic ions, and I put it in. I put it in the study guide for the quiz for this quiz. Okay, so, or if you just join the class, I think I sent a link for that. You can find it. All right, any questions on this one? Why did they not do this? Oh, they did this. Part of it. All right, so now we have to give the formula. And we have a metal, and we have a polyatomic ion both. Come on now. All right, so we have iron 2 hydroxide. What does that Roman numeral tell me? Ooh, no. That's a common misconception. The Roman numeral does not tell me how many I have. What does it tell me? Actually, it can tell me 2 things. Remember I told you this was number 4? Write this down. Roman numerals mean they're only for transition metals. So that Roman numeral tells me iron is a transition metal. Okay? It also tells me the charge. So maybe that should be number 5 that we write down. Roman numeral tells the charge on a transition metal. Roman numeral gives the charge on a transition metal. Okay, so that Roman numeral 2 means that iron is a +2 charge. Okay, hydroxide. Again, this is another polyatomic ion. And it is OH, and it's a -1 charge. So, gotta have those memorized. It's a -1 charge. So, if iron is +2 and hydroxide is -1, that means they have to balance out, right? So, would I have more hydroxides or more irons? Do I need more hydroxides? So, so I'm not going to have 2 irons. That would mean this is a +2, +4, and a -1. That would mean +6 and -1. That doesn't balance either. That means this would be +2 and -3. That doesn't balance, right? So iron is +2. This is -2. Okay. We good there? Okay, please make sure you're staying focused on doing this. I know that there are a lot of assignments listed there in Schoology, that you have worksheets, you have math problems, you have all of those things. Please do not take review time to do those things. Review time needs to be review time, okay? Even if you wind up turning those other things in late, it would be worth it for you to stay focused on reviewing for the test. So please make sure that you do that. All right, so let's look at our next question. So name the following compound, AsCl5. All right, so the first thing I have to ask is, do I have a metal or do I have a metal in here? So look on your periodic table, because again, I don't expect y'all to know every metal that's out there or every non-metal that's out there. Look at the periodic table, find where it is on the periodic table, and tell me if it's a metal or a non-metal. It's not a metal. As is not a metal. What about Cl? No, 2 non-metals. So number 6 to write down. 2 non-metals. And again, this we learned in Unit 3, is covalent. It's a covalent compound. So you're going to follow the rules for covalent compounds. And those rules say you put a prefix that tells you how many of each element you have. And that's it. It's the end of the story. Okay? So I have 1 arsenic and 5 chlorines. If I only have one of the first element, my rules say don't put a prefix on the first element, put it on the second element. So this one would be incorrect because I'm not going to I don't put mono on the first element ever. We don't start names with mono. Okay, just viruses. Never mind. All right, so this one looks like I have 1 arsenic and 1 chloride. So that's not it because I have 5 chlorides. This is arsenic pentachloride, so this is correct. The last one is incorrect because astatine is AT, not AS. Again, you will know that because you will have a periodic table. Okay, so please make sure that that's not a memorization thing, that's just reading it off the table. Okay, questions there? Covalents are the easiest ones to name because all you do, you don't got to worry about charges. All you have to do is put the prefixes in the right place. That's it. So they're super easy. All right. So let's look at this one. Do we have a metal? That needs to be the first question you ask yourself whenever you come across a formula. Do you have a metal? Na. Is Na a metal? Where is Na? Group 1. It's group 1 metals? Yes, they're on the left side of the periodic table. Group 1, group 2. Basically, group 3 through 12 are metals. All of them. So 1 through 12. Sorry, I said 3. Group 1 through 12, all of those are metals. All the time. So we have a metal. Is it a transition metal? No. Got that one. Not a transition metal. What charge does it have? +1. Okay, so that was my first question I asked. Is there a metal? Second question, do I have more than 2 elements? Yes. So I've got a polyatomic ion in here. NO3 is what polyatomic ion? Nitrate. So I know this is nitrate, and it has a -1 charge. Not that that really matters for naming it, but. So this is nitrate, and this is sodium. The charge is balanced. It's a metal. I don't use prefixes, so the second one is out. I don't need a Roman numeral because it's not a transition metal, so that one's out. Again, I don't have prefixes. That one's out. Sodium nitrate. That's all there is to it. Okay. Okay. So let's take a look at this one. First question, do I have a metal? Nitrogen, hydrogen, fluorine. Where are those on the periodic table? Hydrogen's in group 1, but hydrogen is not a metal. It's the exception. Like every rule we have in chemistry, there's at least one exception. So hydrogen is not a metal. Then no, there are no metals. Okay, there are no metals. This is all covalent. Do I have more than 2 elements? Yes. So that means I have a polyatomic ion. NH4, you should have memorized, is the polyatomic ion ammonium. Okay, so this has a +1 charge. This has a -1 charge. The charges balance. So there's no metals in there. I gotta back up. I made a mistake. There's no metals in here. That is correct. But it is also not, it's also got charges in it, +1 and -1. Those charges balance. So even though there's not a metal, we're actually going to follow the rules for ionic compounds in that we are not going to put prefixes. Okay, because there is only one way to make ammonium fluoride, and that is with 1 ammonium and 1 fluoride. We cannot have anything more than that, so there's no point in putting a prefix. Prefixes are for covalent compounds where we can have lots of the same elements making different compounds. Hey, what? No,
We have Pop-Tarts and bars.
Pop-Tarts or bars for breakfast? Anybody? Is he gonna water?
Sure.
Yeah. So, like with carbon and oxygen, we can have CO, we can have CO2. They both have the same element in it. So we need to come up, thank you, we need to come up with some different names for CO and CO2. So that's why we put in the prefixes. We can't just say carbon oxide because we wouldn't know, is it carbon with 1 oxygen or carbon with 2 oxygens? So we break it up and we say carbon monoxide or we say carbon dioxide. But with this compound, ammonium fluoride, there's only one way to make it. 1 ammonium, 1 fluorine. 2 fluorine, you can't put 2 fluorines in there, you can't put 2 ammoniums in there. One way to do it. So putting a prefix is redundant. We don't need to do it. Okay? Why is Clarksville High School calling me?
Answer it.
They just hung up. Okay. So that's why, again, we don't have the Roman numeral because there's no transition metal. We don't have the monofluoride thing because it actually follows the rules of ionic compounds because there's no, there's 2 charges involved. Ammonia is not NH4, that's NH3. So it has to be this one. It's in the floor.
Oh, I was thinking that might.
Yeah, I know, I was too for a second, but all I got is PHS Bell's normal. So I guess they're just calling to tell me that the Bell schedule is normal, but probably the bells will be turned off. But it doesn't ring. Did y'all hear it ring? It didn't ring, did it? My phone rang. Okay. Oh well. I don't know. All right, so we are just about to the last one on this one. I'm not going to go over the 10th one because we all got that one right. Well, we might not be going over this one either. Here we go. All right. So on this one, we have dihydrogen. Is that dihydrogen or dinitrogen pentoxide? Come on, it's being slow. If you don't see any prefixes in something, so if you're looking at a name of something and you don't see any prefixes, you can chalk it up that it's ionic. Either it has a metal or it has two opposite charges like the last one we did. Because if it's covalent, at least the second one will have some sort of prefix on it. Okay? So that'll let you know it's covalent, and that makes it easier. With covalence, you don't have to worry about balancing charges. You just write however many the prefix is, that's how many is there for. So we have dinitrogen pentoxide. Neither one of those are metals, so that's a covalent compound. So that means I have 2 nitrogens and I have 5 oxygens. So it's that one. Okay, drop and swap is only for ionic compounds. So that's a perfect thing to figure out with this review. Because if you've been doing drop and swap on covalence, you're going to get them wrong every time. Those are only for ionic compounds. So you might want to make a note of that. Okay. The drop and swap is only for ionic compounds with metals or charges. Okay. Covalent compounds do not have a charge. So like this one, it's got prefixes in it. If it's got prefixes, that tells you it's covalent. That means there's no charge. That means you just take the prefix, and that's how many there are. Super easy for those. Okay? Like I said, we all got the last one right, so I might look it up. All right, so let's go back and let's look at quiz number 4. And we'll go through a few of those. Let's see. That would have been the Friday previous.
I haven't taken this quiz. I gotta take it tomorrow.
Okay, then we'll do quiz number 3. So we're gonna look at quiz 3 now.
I'd rather just tell you that join the next time and you say you can't take it. You're very anything, and then I just go.
No, yeah, you're right, Tim. So was that the 8th? That been the 8th? Nope, obviously not. No, it must have been. Oh, quiz 3 was in. That was in the second 9 weeks. That was the one we took on the day that we left
Here it
for
is.
Christmas break.
It's in number 8. It's in day 8. Day 9. And it's like the naming quiz.
Day 8?
No, day 9.
Day 9? I thought I opened day 9.
It says read the finished naming quiz for the ionic covalent.
Okay. Oh, yeah, looked right over it. Okay, now on this one was easier because for some of them, I told you, or one of my quizzes, maybe it was quiz number 4, I told you if it was ionic or covalent or an acid. I'm not going to tell you that on the test. You've got to be able to identify those things. Okay, so you got to be able to look at something and tell this is an ionic compound, this is a covalent compound, this is an acid. An acid is something that has a hydrogen in front and a polyatomic ion behind it, or maybe just a single element behind it. Oh, goodness. Why are you doing so slow? Okay, let's just do this. Let's just do a preview. All right. So name the following compound, SO3. So again, does it have a metal in it? So look on your periodic table, find S, find O. Are they metals? No, they are not. If they are not metals, you are just going to use prefixes. It's just a covalent compound. So all we're going to do, so sulfur oxide, there's 3 oxygens in here. So that's out. No Roman numeral because there's no metal. And we don't ever put a prefix on the first element. So that one's out. So it has to be sulfur trioxide. Questions on that? Okay. Let's look at the next one. So, do I have a metal? Fe. Is Fe a metal?
Yes.
Yes, it is. It is iron. CO3. That's a polyatomic ion. And it is the polyatomic ion carbonate. So again, you need to go back and memorize your polyatomic ions and their charges. Carbonate is a -2 charge. Yes. Is that right? Let me double check. Yep, it's -2. Okay. Just checking. All right, so if carbonate is a -2, what does the iron, and there's only one of them. I can look here and see there's just one carbonate and there's just one iron. So if carbonate is -2 and there's one of them, what does the charge on the iron have to be? A +2. So this one's out because the iron, you have to have a Roman numeral. Why do I have to have a Roman numeral for the iron? What kind of metal is it? Transition metal. So I have to put a Roman numeral. So 2 is out. That's the wrong Roman numeral, and we never use prefixes with metals. So it has to be this one. Okay? All right. Okay, so this one is a acid, and I give you a hint. Think about polyatomic ion in the formula, and here's our formula. If there's an H in front, anything that starts with an H is an acid all the time. Okay. So ClO4 is our polyatomic ion, and that is the perchlorate ion. And our little mnemonic device says if our polyatomic ion ends in 8, then our acid ends in IC. Okay? E. All right? So this is, and we don't have any prefixes, we don't have any hypos, any hydros, nothing if the acid has a polyatomic ion. So that might be number 7. I think we're up to number 7 now. Things to write down. No hydros in front of an acid with a polyatomic ion. Okay, so that's going to take out that one. Or actually, I'm sorry. That's going to take out this one. Okay? Hypoperchloric acid, that's a different polyatomic ion. Okay? So that comes out. Perchlorous acid would be if the ending was ite, not ate. So that makes that one out. So it's perchloric acid. Okay? Okay, so on this one, do I have a metal? Yes or no? Do you have a metal? Huh? No? Do I have an H in front? No. So it's not an acid, and it's not an ionic compound. Are the phosphorus and the oxygen nonmetals? Yes, they are. So all I do is look at the prefixes. How many phosphoruses are there? 2, because prefix is di. How many oxygens are there? 5, because the prefix is pent. So this means 5, this means 2. That means that can't be it, that can't be it, that can't be it. And remember, covalence, there's no drop and swap. You just take the prefix as it is. Okay? All right? Whoops. I'm supposed to be doing an eraser, and I'm doing a pen. Oh my goodness. There we go. So what's the correct formula of copper to nitrate? All right, so do I have a metal? Yes. What does that Roman numeral mean? The charge. So the charge on my copper is a +2 charge. What's nitrate? NO3, -1 charge. So how am I going to get a +2 and a -1 to balance out? I need 2 nitrates. I need 2 nitrates. So the first one's out because I only have 1 nitrate. The second one's out because I have 3 coppers. I don't need 3 coppers. Okay. The fourth one's out because, again, I don't need 2 coppers. So this one is the correct one because each nitrate is a -1 times 2 is -2, and my copper is a +2. Those balance out. Those charges balance. So that's my formula. Okay? Okay. Do I have a metal in this? Is there metal in here? No. Do I have a hydrogen in front? Yes. I have a hydrogen in front. Do I have a polyatomic ion? No. So if I have a hydrogen, that means it's an acid, but I don't have a polyatomic ion. So all I do is I put the word hydro in front, and that second one, so the hydro means the hydrogen, and the second part of that is the other element, iotic. Iotic. That's iodine, I. And that is it. There's one of each because if you look, iodine is in the 17th column, so it has a -1 charge. Hydrogen's a +1, so there's one of each, so that means that can't be it, that can't be it, and that's the wrong element. Okay? I think we've done this one before, haven't we? I'm not sure. But anyway, same questions. Do I have a metal? Al. Al? Al is not a metal. Okay, I see what you're saying. Al, all right, Al is aluminum. So when you hear that word aluminum, what do you think about? A can. And when you hold that aluminum can, would you say it's metal or not? Yeah, you would. Aluminum, again, is one of those weird exceptions because in chemistry we have all these rules, but we have exceptions to them too. So aluminum, germanium, tin, Sn, lead, Pb, those are all actually metals, even though they're past that group 12. They are still some metals. Okay, they're getting close to being what we call metalloids, which is a weird mix between a metal and a non-metal, but they're not quite there yet. So, do we have a metal? Yes, we do.
We do.
We do. Yes, we do. Because aluminum, as in aluminum can, that's a metal. But it's not a transition metal, so we can take that one out. What's the charge on that aluminum? What column is it? +3. Okay. OH, you should know, is hydroxide. That's a polyatomic ion. and it has a -1 charge, and I have 3 of them. So that's -3. So those charges balance. So if it's a metal, am I going to have any prefixes in here? Nope. So that one's out. Oxygen hydride is not the name of OH. So that one's out. Okay.
What is that?
It's my phone going off.
Oh. Sounds like that.
I would keep it on silent, but I'm on the list for a vaccine whenever they start giving them to teachers. And something about you have to be called by the health department and you have to answer and all this kind of stuff. So I'm always afraid they're going to call and I'm going to miss my chance. So I always look and see where it's from, but that was from Massachusetts, so I don't think that's got anything to do with my vaccine. Okay. All right. So here's another one. Rubidium acetate. So look up where is rubidium on the periodic table. You're probably going to need to use the one in the black book. Rubidium is Rb, but you need to know where it is to answer our first question. Is it a metal? Is it a metal? Yes, it is. It's in group 1, so it has a +1 charge. Acetate is a polyatomic ion that you have to memorize, C2H3O2, and it has a -1 charge. So they balance each other out already. Is rubidium a transition metal? Huh? No, so cross that one out. Do I need 2 acetates to balance this? No, so I can cross that one out. Do I need 2 rubidiums to balance the acetate? Nope, so I can cross that one out. It has to be that one. All right. So here's another one. BaSO3. So do I have a metal? Yes or no? Do I have a metal? Yes, I do. What is it a transition metal? No, it is not. So I can cross that out. I can cross that out. SO3 is a polyatomic ion because it's more than one element, so it means it's a polyatomic ion. SO3 is actually the sulfite ion. Okay, so that takes this one out. And so that means it has to be the first one. Barium sulfite. Okay? Okay. Aluminum phosphate. So aluminum is Al. What's the charge on aluminum? +3. Is it a metal? Yes. Phosphate. What is phosphate? Polyatomic ion, and it's PO4 with a -3 charge. So they balance each other out, right? So I just need one of each, which means
Page in there, gives you to check your phone and to post it, she said.
I couldn't do it either. And
You want to talk to her? She said.
let me just try it. If it's working out, and then I'll.
Billy doing the PSAT?
Please.
Billy doing the
Yes.
Nathan, PSAT? Nathan,
Yeah.
Tyler, I know he just did Zachary, yes. Anna,
Yes.
Kristen, you're here, Danielle,
Yes.
Brody,
Do not. I don't think Brody is. He might be.
y'all are here. Garrison,
Yes.
you can tell I just posted.
Okay, Miss Peter said she just posted.
Oh, it's still not on the wall, and it's not ringing. It's not on the wall, but it doesn't ring.
Okay, she said her phone is not working and it's not ringing. Okay, thank you. You're welcome. If you need anything, let me know.
Now I can call out on it, but it's not ringing. Okay. All right, so, all right. So we can take out the last one because PO2 is not the formula for phosphate. I can take out this one because I do not need 3 of them. And I also do not need 2 aluminums to match with 1 phosphate. They're both +3 and -3, so it has to be this one. Okay. All right. So, any questions on naming compounds or writing formulas?
Can you name all the exceptions one more time?
Exceptions, okay. Silver is a +1. I believe zinc is an exception, but let me double check and make sure. For the most part, zinc is a +2. So silver is a +1, zinc is +2, and that's all the exceptions for the transition metals. Hydrogen is always a +1, even though it's in group 1, it is not a metal, and it's a +1 charge. Okay? So what I would do as far as identifying something as being a metal or a non-metal, let me pull up a periodic table. What you want to do, because you'll have a periodic table on your test. So basically, anything, so if we kind of drill a line right here, anything here and up, these are non-metals. Anything here and over, those are all metals. And the line is this right here. These are what we call the metalloids. And we learned all this at the very, 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 very beginning of the year. Okay? So things like aluminum, tin, lead, all of those from here over, those are all metals. Everything in the top right-hand corner here, those are all non-metals. Okay? That's the easiest way to do it. And like I said, you'll have your periodic table. So all you got to do is look at, is it past that dividing line, or is it to the right of the dividing line, or is it left? If you use the one in the black book, your dividing line are the orange ones, the light orange ones, right through there. Those are your metalloids. So anything here and over, blue, red, blue, purple, all those are metals. Anything green, brown, or purple on the left side, or right side, non-metals. Okay. All right. Oops. Okay, so let's move on to some math problems. So unit multipliers are the math problems that we've done here. So we're going to look at a few of those calculations. So I would go back to the practice problems that we did. I'm not going to take time to erase all that. And pull those up. So let's pull up the one on molecular mass and mole calculations. I believe that was in Monday's date.
It's,
Day 12. So if you open up day 12 and go to the practice problems and just download both of those. With molecular weight, that's super, 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 super easy. Okay? All you do for molecular weight is you simply add up the atomic mass from the periodic table, the atomic mass of everything in the formula. The subscripts tell you how many of those things you have. So, for example, on the first one, that subscript 3 means I have 3 hydrogens, I have 1 phosphorus, and I have 4 oxygens. So all I do is I go to my periodic table, and I look up, and of course the periodic table I picked doesn't have atomic mass on there. Great. So let's get another one. That one doesn't either. Good grief. Here we go. The one you have in your book does. So here it is. So I look up hydrogen. The atomic mass is the decimal number. So when you're looking up your periodic table, it's the decimal number. So hydrogen is 1.008. Phosphorus is 30.97. And oxygen is 15.999. Okay, so basically what I can do is I can say 3 times 1.008. I can say 30.97, and then 4 times 16. It's 15.99 is pretty much 16. I just multiply those, add them all together, and I'm done. That's it. Okay?
Hey there.
Hey.
I'm just gonna plug the phone.
Okay, that's fine. It didn't rain.
Oh, I know, they
Right.
left, first of all, they left it in the floor.
Yeah.
And
So
you're
I
not the
figured
only
they
one.
weren't. I figured they weren't done with it. So.
Yeah, I'm hoping not.
So when I add all those up, the units that you're going to put on those is grams per mole, because that's how many grams are in 1 mole of that substance. Remember, a mole is just a unit, like a dozen. A dozen. When I say I have a dozen pins, how many pins is that? 12. Okay. If I had a mole of pins, I would have 6.022 times 10 to the 23rd pins. That's a lot of pins, but anyway. So it's just a unit that tells how many of something there is. Okay. Since it's such an enormous number, we tend to focus on, we don't talk about how many there are as much as we talk about what its mass is, because that's a whole lot easier to deal with than trying to count out 6.022 times 10 to the 23rd of those things. Okay. Remember when we did that whole poll about the chicken and the quail eggs and all that kind of stuff? That's what we were getting to. Okay. So when I add all that up, it gives me the grams per mole. And that's all there is to that. I mean, that's just like super easy. On this one here, the only thing you would do different is you would do 1 copper, 1 sulfur, 4 oxygens, and then you would do 10 hydrogens and 5 more oxygens. Okay, because I have all these waters in here, means I have 5 waters. Okay, so I add up 1 copper, a sulfur, 4 oxygens, and then I do 5 times 2, that's 10 hydrogens, and 5 times oxygen, that's 5 more oxygens. Okay, so I think copper is 60, I think it's 64. So we're going to round it anyway. Sulfur is 32. And again, you'll have a periodic table. I don't expect you to memorize these. 4 oxygens would be 4 times 16. Then I have 10 hydrogens. That would be 10 times 1.008. And then I would have 5 oxygens, which is 5 times 16. Add all that up, that's my answer. Make sense? That should be easy. Okay, then let's move on. Okay, come down here. Express the following in grams. So all I'm going to do now is I'm going to convert moles to grams. Whenever it says to convert something or to change the units, that's when you use those, I think y'all call them railroad tracks. Okay, so we're going to set them up. If I have 1 mole of KBr, what unit am I going to put on the bottom? If I want to get rid of moles and get to grams, what unit's got to go on the bottom? Moles. So remember that lab we did at the very beginning of the year where we had Bugs Bunny and Roadrunner and all those, and we had to put them in opposite places? It's the same thing, okay? So if I want to get rid of moles, I put moles in the bottom, moles KBr. And in 1 mole of KBr, to find the number of grams of KBr, I just add up the mass of potassium and bromine. So I looked that up on the periodic table. I think potassium is 40, bromine is 79. So what is that, 119? Okay. Something. On a test, you're not going to want to round those numbers. You're going to want to carry them out. But for convenience sake, I'm just rounding it. So then I would just multiply across the top and divide by what's on the bottom. So what's 1 times 119? We can do this with our calculator, right? 119. 119 divided by 1 is 119. Abby. All right, so let's skip on down. Let's do number 4. Same thing. So if I want to get rid of moles and I want to turn it into grams, moles on the bottom. That's why I had to do all of these. So many of them. So that it becomes just second nature. So in 1 mole of KNO3, how many grams do I have? I have 39. Is that 39 even? 39.1. Yeah, so 39.1 plus 14 for the nitrogen plus 3 times 16 for the oxygens. So 3 times 16 is 18, 48. Yeah, 48 plus 14, 64. 64 plus 39. 101. 101 point, let's just say 101.1. Okay? So I multiply what's across the top. So I'm going to take 0.5 times 101. That's my answer. Divide by what's on the bottom. There's only 1 mole on the bottom, so that's not hard to do. And that's it. That's my answer. So what is that? About 50 something or another? 50.5 grams KNO3. Okay? And you do all of those same way. Only on some of these, like when they give you the name, you're going to have to give me the formula first, which is why we've spent all this time learning how to write formulas from names and vice versa. Okay? So that should be pretty easy. Yes, ma'am.
Remember, like, the ones that have, like, the times in them?
Yes.
Those
Okay.
confuse me.
Yes, let's do one of these. All that is scientific notation, okay? Which means you have to know how to do that on your calculator, because every calculator is different. You have to know how to do it on your calculator. So same setup as you've done before. So what unit's going to go on the bottom? So I'm going to have moles of HC2H3O2 and grams of HC2H3O2. And in 1 mole, How many grams of that do I have? I'm going to add that up. So let's just use round numbers just for convenience sake right now. So it's going to be 1 for hydrogen. 2 times 12 is 24, so that's 25. Plus 3 more hydrogens would be 28. Plus 2 oxygens would be 32. So 28 plus 32 is 50. Did I do that right? Okay, 50 grams. All right, so now is where I have to put in my scientific notation. So I'm going to get my calculator, and I need a scientific calculator. So here we go. All right. So in your calculator, you want to look for the key that says EXP. It could also be capital E, capital E. Okay? So you're going to put in 1.26 EXP. Do not put times 10. Okay? Don't do that. And then put in the exponent. Put in -4. All right? And then you are going to multiply it by 50 equals. That's my answer. Okay? You can leave it like that, or you can put it back in scientific notation. If you put it back in scientific notation, that would be 6.3 times 10 to the -3, because I moved it 3 places over. 1, 2, 3. 1, 2, 3. Or I can just leave it like that. I don't care. And that would be grams, of course. That help, Zoe?
You lost, I know that, okay, figure out that, you lost one of the calculations. The calculator.
Okay. On your calculator, do you have a key that looks like this one that's being highlighted?
E, then there's an X with a -1 over.
No. I don't think that's the one.
Something like that. It's supposed to be just an E.
Let me bring it here. Because they're all different.
If I did second, I put it in second and push this one. He gives me an E.
Yes. But you got to put the number in first. You got to put in the 1.6 first. And then hit that. So really get to know your calculator, because they're all different. And even the ones, I mean, I do put a calculator, a scientific calculator on your test, but you got to know which button to push. And I'd rather use my own as to use one that I've never used before. So, but you do have to put in some time outside of here to get to know it and get to know how to use it. So did that work?
And that one is 1.6.
So put in 1.26, hit that little E thing, and put -4. Okay? And then hit your multiplication key.
Okay. Times 10.
Times
No, times 50.
times 50. Yes. Did that do it? Okay. All right. So you just need to practice with that. Okay? That's where sometimes Googling things is, we have shot ourselves in the foot on that. We don't have that good old handheld calculator. We just Google, what's this? And then we don't know how to do it. So, okay. Let's do the reverse now. So now we're going to do the same setup, but we're going backwards. We're starting with grams, and we got to go to moles. Okay, so set up those railroad tracks. Anytime you have to convert, you can set up your railroad tracks. If grams is what you're given, where's grams going to go? On the bottom, because I want to get rid of it. What I want to get rid of goes on the bottom. So grams of lithium bromide on the bottom. And what am I trying to get to? Moles, so it's got to go on the top. So I just add up the masses of lithium and bromine. So lithium is 7, bromine is 79. So 7 plus 79 is 86. That's for doing a calculator all the time. Can also hurt you because you can't add 7 and 79 real quick. So 86. Okay, so then I multiply across the top. So 86.84 times 1 is 86.84. I divide that by 86, and I have approximately 1. Okay, so 1 mole. On your railroad tracks, you always multiply across the top, divide by what's on the bottom every time. Okay, and all those you'll do exactly the same way. Again, that's why I had y'all do umpteen bazillion of these. Okay. Percent composition, that's super easy as well. So all we're going to do for percent compositions is we are going to find the molecular mass first. So you're going to add up the mass of all the elements in there first. And then you're going to take the mass of the specific element it asked for and divide by the total. Because remember from math, percent is part out of the whole. Okay, so on 41, if I want to know the percentage of strontium in strontium chloride, first I got to find out how much strontium chloride weighs. So 2 chlorines is 35, and strontium SR is 87.6. So let's say 88. 88 and 70 is 150. So strontium chloride is 150, I'm rounding, grams per mole. So if I want to know the percent strontium, that would be the 88 grams for strontium divided by 150 grams per mole of strontium chloride, and then I multiply by 100. So 88 divided by 150. And that's your answer. Times 100, sorry. I always move it over 2 decimal places. So what does that come out to do? Because I can't do that in my head for sure. It's time for break. Okay, 88. Not 888. 88 divided by 150. And then so it'd be 58.7%. Okay. All right, so let's take our break and then we'll come back and finish up more problems. If you're still eating your break, keep eating, whatever. That doesn't bother me to eat while I talk. Okay. So that's percent composition. So the main thing to remember about that is you're going to add up the mass of all the elements in there. And then you are going to divide that total number by the percent that you happen to be looking for. So let's do one more. Let's do 45. KMnO4. So KMnO4, we need to find the total mass first. So that would be 4 times 16 for the oxygens, which is 64. Plus manganese, which is 54 or 55, if I'm looking at that right. I'm just rounding up. In a test, you would not round up to the whole number. I'm doing it just for convenience sake. And potassium is 39. So we would add all those up together. That's going to be 18, 7, 10, 158. Okay, as your total. So to find the percent oxygen, I'm going to take my 64 for oxygen, and I'm going to divide by 158, and then I'm going to multiply by 100. Yeah, that sounds about right. Percent oxygen. Okay. So any questions on those? Those tend to be pretty easy. Okay. All right. Then let's take a look at the one for tonight. The mole ratio worksheet. Okay. Now, on this one, they have been Very nice in that they are giving you a nice balanced equation. By balanced means we have the same number of things on both sides. Okay? So on this one, I have 2 nitrogens. Over here, I have 2 nitrogens. I have 3 times 2, which is 6 hydrogens. Over here, I have 2 times 3, which is 6 hydrogens. So everything's balanced out. The mole ratio just tells us when we compare 2 things, it tells us how many of each we have. Just if I compared girls to boys in here, I would have 4 girls for 3 boys. That would be my ratio. I'm just counting how many there are and comparing them to each other. Okay? So the ratio for nitrogen to hydrogen, okay, I would look here. There's no coefficient in front of the nitrogen. That means it's an understood 1. And there's a 3 in front of the hydrogen. So my ratio is 3 to 1. That's it. That's all you gotta do. Okay? Here it would be 1 to what? How many ammonias are there? What's the big number in front of the NH3? Up here. 2. 1 to 2. Does that make sense? Your brow is very furrowed. The ratio is the coefficients in front. I just make a ratio out of them.
So, B and C be the same.
Like in math, a math ratio. I make a literal math ratio.
So, B and C be the same thing?
Yes. No. C is not going to be, look at C. H to NH3.
Okay, so
That's a 3. That's a 2.
So we're taking the numbers in front.
Numbers in front.
Okay.
Only using numbers in front for mole ratios.
Okay, so the next
So the next one.
H2. So
All right. So A would be what?
8 and 8.
8 and 8. Which, if we were in math class, and we're going to pretend like we are, would you leave that ratio 8 to 8 if you were in math class? What would you put it down to? 1 to 1. We do the same thing in here. 1 to 1. Yes, ma'am.
What do we get for B again?
We got
1 to 2.
Yeah, 1 to 2. All right, so B on the second one. What's that going to be?
8 to 1.
8 to 1. And C?
8 to 1.
8 to 1.
Okay.
All right, so now it's getting a little more, we're working our way out, getting a little more difficult. So answer the following questions for this equation. Our equations are still balanced. So what's the ratio of hydrogen to water? 2 to 2.
Which equals 1 to 1.
Mm-hmm. Yep. So we would just go ahead and reduce that down and say we have a 1 to 1 ratio. Now, here's why we need to do that. We're going to start using these to actually work some problems and figure some stuff out. So if I had 20 moles of hydrogen on hand and I had plenty of oxygen, how many moles of water could I make? So you're going to set up your railroad tracks again. On this one, it's actually easy enough to do in your head, but I want you to get in the habit of setting up your railroad tracks again. So we're going to start with 20 moles of H2. So I want to get rid of H2, moles of H2. So where's moles of H2 got to go? If I want to get rid of it, where's it got to go? If I want to get rid of any unit, where's it got to go? In the bottom. Got to go in the bottom. What am I trying to get? Trying to get moles of water. So where's it going to go? On top.
What does that say?
This says moles of H2. MOL. MOL is the weird abbreviation for moles. I know, it just left off one letter. I know, it doesn't make any
It's like
sense.
the actual abbreviation
It is the actual chemical abbreviation of mole.
I thought you were just. doing
Nope.
that.
Nope, it's not just me. So yeah, it's weird. I don't know. So I have my units. My moles are canceling out, but I gotta have some numbers to go in there. So according to my ratio, how many moles of H2 are there for moles of water? What's my mole ratio? 1 to 1. 1 and 1. 20 times 1 is 20. 20 divided by 1 is 20. So my answer, 20 moles. Now, like I said, if you had thought about that one, you could figure that one out in your head without the railroad tracks. But I want you to get used to using them, Tristan. Shut up. So that when they get the numbers get a little weird and harder to figure out, you'll know what to do and you won't just like freak out. Okay. So what is the ratio of oxygen to water? Go back up to our equation. What's the ratio of oxygen to water? 1 to 2. 1 to 2. Now remember, I can write a ratio with the dots or I can put a fraction line. It's the same thing, right? Mathematically. So we're doing the same thing that we would do in math. All right, so now it says, suppose you had 20 moles of oxygen. You had plenty of hydrogen, so we're not worrying about that. How many moles of water could you make? So now we want to change our moles of oxygen to moles of water. Set up our railroad tracks, use our mole ratio. So 20 moles of O2. And so where's moles of O2 going to go, top or bottom? Bottom. And what am I trying to get to? Moles of H2O. So if I look in my ratio, for every 1 mole of H2O, how many moles of water do I have? For every 1 mole of O2 right here, there's a 1 right there, how many moles of water do I have? 2. So what's 20 times 2? 40.
Why did that take me so long? Yikes.
Okay? All right, so that's how we use these mole ratios. We use the mole ratios to take moles of one thing and turn it into moles of something else. Okay? We've learned how to go from moles to atoms. We've learned how to go from grams to moles. And now we're learning how to go from moles of one thing into moles of something different. And we use the mole ratio to do that. Okay? All right. So I'm going to let y'all finish that one up on your own. There is actually not a lot of there's not any of this on the test. Okay. Now, there is one thing that might be on the test. So, just listen to this question. So I have NH3 right here. In NH3, how many moles of hydrogen are there?
0.6.
No. Listen. Forget all this. Forget all that. This is not related to that question at all. Just in that compound right there, how would I figure out how many moles of hydrogen I have? Let's take this a little different. Let's say I have 1 mole of NH3. How many moles of hydrogen are there in that? So, set up your railroad tracks. That's where we always start. 1 mole NH3. What am I going to put on the bottom? What am I trying to get rid of?
Does it say 1 or 7?
It says 1. That's a question mark. up there. That's a question mark. Why would I put hydrogen in the bottom? Would it cancel out? If I have ammonia in the top and hydrogen in the bottom, are they going to cancel out? No, so I don't want hydrogen in the bottom. So what am I going to put in the bottom? Just nitrogen? Both of them. Yes, NH3. I'm going to put exactly what I have in the top. So what I have up here, I'm going to put down here. Okay? What does my question ask for? Moles of hydrogen. My personal question, not the one that's up here. My personal question is moles of hydrogen. That's what I want to know. So that goes on top. We're not doing this. We're not doing this. No, not right now. This is my own question. This will be the kind of question you will have on the test. If you have 1 mole of ammonia, how many moles of hydrogen would that be? So I set up my railroad tracks and I look at my formula. For every one of these, how many H's are there? How many H's are in NH3? 3. Exactly. Just because I call it a mole doesn't change anything. For every 1 NH3, I have 3 hydrogens. For every 1 mole of NH3, I have 3 moles of hydrogen. Okay? So how many moles of hydrogen are in NH3? 3. 1 times 3 is 3. Divided by 1 is 3. You add. No, we always multiply. Unit multipliers are all, that's why they're called unit multipliers. We always multiply. Multiply across the top, divide by the bottom. Okay? That kind of question will be on the test. Where I'm going to give you a formula and I'm going to say, all right, how many moles of this are there? Now, here's the other kicker I could do. How many atoms of hydrogen are in there? How do I go from moles to atoms? Somebody's number. It's got a weird name. And it's a monster of a number. Avogadro's number. So I would just take my answer right here. Moles of hydrogen. I'm going to erase this. So I don't want moles of hydrogen anymore. So where am I going to put it? If I want to get rid of something, where do I put it? All right, think of it this way. On the bottom. When y'all are trying to clean up your room and you want to get rid of something fast, where do you usually put it?
On the bed.
Under the bed. On the bottom. Under. Away. So you want it to be gone. Although it's not really gone. But anyway. So 1 mole of hydrogen. And I want to get to atoms of hydrogen. How many atoms are in 1 mole of anything? Y'all said it? You said his name. Avogadro's number,
Yes.
which you need to memorize. 6.022 times 10 to the 23rd. Write that number down if you don't have it memorized already. Avogadro's number, 6.022 times 10 to the 23rd. So then I would just take 3 times 6.022 times 10 to the 23rd, and that would tell me how many atoms there are. 3 times 6.022 EXP 23. Whew, I can't believe they gave me that in actual, hold on. Did I do that right? Yeah, I don't think I did that right. 3 times 6.022. I guess I did. Okay. There's your answer. Do you want to write all that out? No, I don't either. So we need to put in scientific notation. 1 point, what was that? 806. times 10 to the 3, 6, 9, 12, 14, 6. No, that's not right. 3, 6, 9, 12, 15, 18, 21, 22, 23, 24. That's how many atoms of hydrogen are in ammonia, or in 1 mole. That could be on the test. So you just need to know how to go from grams to moles and moles to grams, and then how to go from moles to Avogadro's number. But you have to have that number memorized. I'm not going to give you that. So Avogadro's number is 6.022 times 10 to the 23rd.
This class gives me wrinkles. Because I'm always like this.
Yes. Well, instead of doing this, ask your question. Don't just furrow your brow. Ask your question. And that will relieve the stress in your forehead, and you won't have wrinkles. So, do you have another question?
No, I think I got it.
You got it? Okay.
No, I think I got it.
Abby, you got this. You can do it.
Go back through the practice problems, because we have done a lot of practice problems with this. And back through the notes, because your notes give you some practice problems as well that you could do. Like cover them up, do them, and uncover them, see if you got them right. Okay? And just remember, it's unit multiplier. So what you don't want goes on the bottom. What you want to get goes on the top. You just keep going until you got it. Okay. So let's see. I think that's all of that one. Do I want to do this one? No. The hydrates, actually, I'm going to take this off of tonight's homework because hydrates, I'm going to change things and we are not going to have. The only thing of a hydrate that you might have on the test is finding the molecular wet mass of it, which is easy enough. These, finding the percent water and all that won't be on there. All right, the next thing I want to do is I want us to go back to the math problems. Okay, so what was checkpoint 1? Let's look at checkpoint 1. So we're still in day 9. Let's take a look at checkpoint 1. Oh, that was, nah, I'm actually not going to look at that. No. So Zoe, what day did we do the math questions?
Yeah, questions.
Is it Friday? Was it the 19th? Yes, it was the 19th. So if y'all will go to the 19th, we're going to look at these math questions. I haven't graded them yet, so I don't want to do that. Let's do preview. Because you will have questions like this on there. All right, so you have 156.5 grams of palladium. How many atoms do you have? Show all your work. All right, so I'm just gonna type it in like you would type yours in. All right, so what are we given? Whenever you're doing these problems, even when you're doing math problems, what does the problem tell you? What does it give you? And what is that number? No, not literally. What is the number in this problem? 156.5, and give me the unit that goes with it. Grams of PD, palladium. Okay. Now, I don't want grams of palladium. What do I want? What am I asked to find? What am I asked to find? Where's my question? How many what? Atoms of palladium. Do I have a conversion that goes directly from grams to atoms? No. What do I need to do first? I need to go from grams to moles. Okay, so I'm going to go grams to moles. So I'm going to multiply that. And so if I want to get rid of grams, where does grams have to be? On the bottom. So I'm going to say 1 mole of palladium divided by the grams of palladium, which I look up on the periodic table, is 1. Isaac or Jacob, can y'all tell me what that is? Is that 150? PD 46. So
106.42.
106.42. Okay. So what I'm going to do is I'm going to do exactly what it says. I'm going to take 156.5. I'm going to multiply it by 1. And then I'm going to divide it by 106.42. So 156.5. This is another reason why I like handheld calculators, because I don't like the ones on the computer. I always put in a wrong number. 106.4. See? If you're done, yes.
The worksheet, small worksheet.
Yes. All right, so when I divide those out, I get 1.47 moles. And that's my answer. Moles of PD. Obviously, you can't circle your answer. But that's how we do it. Oh, are we done yet, though? Oh, wait. Are we done? What did I do wrong? I didn't do my last conversion. I got moles, but what did my question ask for? Atoms. How many atoms? Yeah. You don't, I think you have, okay. So I'm going to have moles on the bottom. Well, how many atoms are in 1 mole? 6.022
Times 10.
times 10 to the 23rd atoms per mole. Okay, so now I got to take 1.47 and multiply it by 6.022 times 10 to the 23rd. So I'm just going to continue this thread out here. 022 exponent 23. I wish this thing would put this in scientific notation, because that's a real pain. So let's say 8.55, and that is 3, 6, 9, 12, 15, 18,
It's
21, 22, 23. 8.85, that's fine. 8.86 times 10 to the 23rd atoms of palladium. Okay? That makes sense? Your brow's not furrowed, so that's good.
how do you guys?
I know. I'm not saying that you don't. I actually like the furrowed brow because it lets me know, do I need to say something again or not? When you just give me a blank stare, I'm like, oh, y'all got it. Hey, we're good. And then you're like, oh, okay. So make faces at me, whatever. But I need to know that. All right. Now I couldn't set up my railroad tracks like this, and I have no problem with you doing this on paper and setting up your railroad tracks and inserting the image. That's why I put that little thing in there. So even on a test, you'll be able to work it out on paper, take a picture, and upload. All right, let's move on. That's the same thing, but backwards. Okay, so I'm not going to do that one again because I think there was a different one in here. All right. On this one, molecular mass of ibuprofen, they give you this big setup, so read the whole thing. Don't just stop. It's not as bad as it seems. So you have 0.25 moles of ibuprofen. There's the formula. Calculate the molecular mass. You're just going to add all those up together. Okay. How many grams are in 0.25 moles? You're just going to use your molecular mass and change grams to moles. That's not a big deal. Number of molecules, same number. Molecules and atoms, you use Avogadro's number. So you're going to take your answer from B, you're going to multiply it by Avogadro's number. 6.022 times 10 to the 23rd. Okay? Percent compositions, we've already done those. Let me talk just a second about empirical formulas. Remember the difference between empirical formula and molecular formula. Empirical formula is the actual, is the ratio, smallest whole number ratio of atoms. And the molecular formula is the actual number of atoms. So, for example, if I have, and we did this on our POGL, we did an empirical formula POGL, okay, so I would go back and look at that. So if I have C4H8, that's my molecular formula. I have 4 carbons and 8 hydrogens. What would be my empirical formula? What would be the smallest whole number ratio of 4 to 8? 1 to 2. So my empirical formula would be CH2. Okay? And to get my molecular formula, what did I have to do to get my molecular formula? I had to take this and multiply it by what? 4. So the mass of this is 4 times the mass of the empirical formula. On your free response question, that's what you had to do. You had to figure out how many times bigger your molecular formula was than your empirical formula. And then you could multiply by your empirical formula to get your molecular formula. Yes, ma'am.
What time did they
The meet is at 10 o'clock.
Okay.
So you can sleep in. That's not early.
No, I hate anything before 1 o'clock is early.
What?
Well, I'm sorry, but
Oh, we did. So
That's
all the
fine.
ones tonight's spreadsheet, we had to do.
I would do all the mole ratio problems, yes.
Okay. So Lauren did. What
And then the hydrate thing, I'm taking that off. So that will not be
Okay.
there. It's going to be gone. It's gonna
Okay, the thing
disappear.
that we were gonna do today is taken off?
Yes.
Okay.
So the only thing on there for today will be the review. And we'll talk about the lab later too. I'm not going to worry about that right now.
Okay.
Okay?
I'll stay.
All right, bye. Aubrey, did you get all that? Aubrey's no longer with us. I hope she did.